Welcome to PlayOwnAi. In this tutorial, we're going to build a private AI-powered RAG application, a solution designed to help you stop paying for costly LLM API fees. We'll be using Ollama and LangChain in Python with VS Code. This is the complete beginner's guide to building a smart, real-time AI solution. Our journey begins inside project directory. First thing we'll take hrpoai.pdf and llm_introduction.pdf or any PDF in this folder. Use a process called chunking. This breaks down our long document into smaller, manageable pieces of text. From we'll move on to our vector store, using ChromaDB to securely store numerical representations of our data. Next, we'll connect to Ollama, our free, local LLM. If we ask, explain PlayOwnAi ID and name card, this is where magic happens. Finally, we'll demonstrate a real-time retrieval and question answering flow. For example, if we ask, explain tokenization, single quote, application will retrieve relevant data from our PDF and generate a perfect, context-aware answer right on screen. Key learning objectives. 1. Setting up the environment. 2. Document loading. 3. Text chunking. 4. Connecting to an LLM. 5. Retrieval-based question answering. 1. Setting up the environment. If you have already set up a Python environment with the necessary libraries, you can skip this step. Otherwise, follow these instructions to get started. Learn how to install and configure the required Python modules, including LangChain Community, Unstructured and ChromaDB. Understand why these libraries are critical for document loading, processing and retrieval. 2. Document loading. Explore how to automatically read PDF files from a directory. Use Unstructured PDF Loader to extract clean text from documents. See how to manage multiple files efficiently. 3. Text chunking. Discover how to split large documents into manageable chunks for better processing. Apply the recursive character text splitter to control chunk size and overlap. Understand why chunking improves retrieval accuracy and efficiency. 4. Connecting to an LLM. Learn how to connect Ollama with LangChain using Chat Ollama. Understand the parameters like model selection and temperature to control outputs. 5. Retrieval-based question answering. Build a retrieval QA chain that links your documents to the language model. Ask natural language questions, like, explain tokenization, and receive context-aware answers. See how retrieval makes responses more accurate and grounded in your data. Check mark by the end of this tutorial. You will have built a complete pipeline that 1. Reads PDFs. 2. Processes and chunks them. 3. Connects to an LLM. And 4. Enables retrieval-augmented question answering. Open terminal. Check if Ollama is installed and running using a few simple commands. Ollama version or Ollama list or sudo systemctl status Ollama. Now, let's get Ollama installed. First, head over to the official website at ollama.com/download. If you're using macOS or Windows, simply click the download button for your operating system and follow the standard installation process. For those on Linux, we'll use the command line. Open your terminal and run this single command to install it. These two commands to add your user to the Ollama group and set the correct permissions for the models directory. Once that's done, you can verify your installation by typing Ollama version This should confirm that Ollama is installed and ready to go. That's it. Now that we llama 3 or DeepSeek R1 to view detailed information and get the exact command you need to run. To start, let's try a smaller model. Let's try a more powerful model like Llama 3. We'll use the latest version to get the most up-to-date model. In your terminal, type Ollama run Llama 3, latest . Again, Ollama will download the model for you. It might take a bit longer, but it's worth it. Once it's ready, let's chat. I'll start with a simple greeting. Hi. The response is much more conversational. Hi, it's nice to chat with you. Is there something on your mind? Now. First, we need a code editor. I highly recommend Visual Studio Code, which is a powerful and free editor. Go to code.visualstudio.com/download. Download the version for your operating system and follow the simple installation steps. Next, we'll install Python 3, which is the programming language we'll be using. Visit the official download page at python.org/download/source. Download the latest version for your system. A quick tip for Windows users: make sure to check the box that says Add Python to path during installation. This will save you a lot of hassle later on. If you're on a Linux system, Python 3 is often already installed. To verify your Python installation, open a new terminal or command prompt and type Python 3 version. If you see a version number, you're all set and ready to move to the next step. We'll get you set up with Jupyter in VS Code, enabling powerful interactive programming and data analysis. First, let's open VS Code from your terminal. Just type code and press enter. Once VS Code is open, we need to install the Jupyter extension. The easiest way is with a simple shortcut. Press Ctrl+Shift+X. This opens the extensions view, a sidebar where you can browse and manage all your extensions. In the search bar at the top, type Jupyter. Click Install on the official Jupyter extension from Microsoft. This will also install other necessary extensions for a full experience. Now, let's set up a project environment. For a clean workspace, it's a good practice to use a virtual environment. Let's create a project folder. In your terminal, type mkdir POI agent to make a new directory. Next, go back to VS Code. From the File menu, select Add Folder to Workspace and choose the new POI agent folder. Now, navigate into your new project folder in your terminal. You can do this by typing cd POI agent. Next, we will create the virtual environment. Type Python 3 mvenv. This command creates a new, isolated Python environment named venv in your project folder. Finally, you need to activate this virtual environment. If you are on macOS or Linux, the command is source venv bin activate. Your terminal prompt will now show the name of your virtual environment, indicating that you're ready to install packages and start using Jupyter Notebooks. Now, let's install the core framework we'll be using for our project. LangChain LangChain is a powerful framework that will allow our Python code to easily communicate with Ollama. You can find more information and the official documentation at python.langchain.com. To install the specific package that connects LangChain to Ollama, open the terminal in VS Code. It's important that you do this from within our project folder, which contains our virtual environment. Type the following command: pip install LangChain Ollama. This command installs the library we need to access Ollama's features from our code. Once that's finished, our entire environment is set up and ready to go. To start coding, our project folder will new folder for Python, like PlayOwnAi agent, venv, lib, Python 3.13. Let's create a new file in our project folder. We'll call it Start Here, IPYNB, which is a great format for an interactive notebook. Open File menu, create new file as Jupyter Notebook, IPYNB support file. Now, let's start working in our Visual Studio Code environment. We need to give a title. Open your Start Here, IPYNB file. In the first cell, click the plus Markdown button. This will create a new Markdown cell. Inside this new cell, type a title using the hashtag symbol, like this, #start here. Now, you can either click the green check mark to save the cell or simply press Shift plus Enter. This will render the Markdown and save it as the time, and type in a new name. Now that our notebook is titled and saved, we're ready to move on to the next step. Right side kernel menu. We can see the kernel is set to Python 3.13x. Clicking plus code will open a code cell where we can write our Python code. Print. Hello. Playing with Python is fun. PlayOwnAi. Prompt window. Visual Studio Code. Running cells with venv. Python 3.13.5. Requires the IPI kernel package. More info. Change kernel. Cancel. Install, click it. After install, complete run or execute code block. Output. Hello. Playing with Python is fun. PlayOwnAi. Click the plus Markdown button. This will create a new Markdown cell. Inside this new cell, type a title using the hashtag symbol, like this, #LangChain start. Clicking plus code will open a code cell where we can write our Python code. Pip install LangChain. LangChain Ollama. LangChain OpenAI. LangChain embeddings. Click the plus Markdown button. This will create a new Markdown cell. Inside this new cell, type a title using the hashtag symbol, like this, call Ollama model. Clicking plus code will open a code cell where we can write our Python code. From LangChain_Ollama import chat Ollama. LLM chat Ollama. Model Llama 3. Latest. Base URL localhost 11,434. Temperature 0.7. Max tokens 1000. Versus code terminal type. Ollama list. That show the models available in your Ollama server. Click on execute cell to run the code. It will execute it without any error. In terminal, run Ollama list to see the available models. To run the model, use Ollama run less than model underscore name greater than. For example, to run the Llama 3 latest model, use Ollama run Llama 3 latest. You can also use Ollama run Llama 2 to 7b to specify a particular version of the model. To run the model with a specific prompt, use Ollama run Llama 3 latest prompt, your prompt here. Click the plus Markdown button. This will create a new Markdown cell. Inside this new cell, type a title using the hashtag symbol, like this, Hash invoke message with LangChain. Clicking plus code will open a code cell where we can write our Python code. Response equals LLM. Invoke. What is capital of Bangladesh? Print. Response. Content. Click on execute cell to run the code. It will execute it and show the output in the cell below. The capital of Bangladesh is Dhaka. In terminal same time type. What is capital of Bangladesh? Hash and press enter. This, in our project create new directory name RAG LLMs. Open file menu, create new file as Jupyter Notebook, IPYNB support file. Now, let's start working in our Visual Studio Code environment. We need save it as title of your notebook. You can now see your new file in VS Code project tree on left side. If you need to rename file at any point, simply right-click on RGLLM, IPYNB in project tree. Select rename. Type in a new name. Now that our notebook is titled saved. In first cell, click plus Markdown button. This will create a new Markdown cell. Inside this new cell, type a title using hashtag symbol. Like this. RAG LLM start. Now, you can click green checkmark to save cell or simply press Shift plus Enter. This will render Markdown. Save it as title of your notebook. Add another Markdown type. Working with documents, PDF in Python. Clicking plus code will open a code cell where pip install LangChain community. Now that our project directory is set up, the first thing we need to do is install the necessary libraries. This is a crucial step that ensures our code will have all the components it needs to run. We'll start with the most important one for this project. LangChain community. You may already have it, but it's always good practice to run the command to be sure everything is up to date. We're now able to use the powerful document loaders within this library. This allows us to easily read and process a variety of file types. Most importantly for this tutorial, our PDF documents. Create a directory named PDF in your project folder. This is where we'll store all our PDF files that we want to work with. Clicking plus code will open a code cell where Python code. Import Oz. From LangChain community, document loaders import. Unstructured PDF loader. Docs folder equals PDF. Documents equals. For file name in OS, list dir. Docs folder. File path equals OS. Path, join. Docs folder. File name. Print. File path. Loader equals unstructured PDF loader. File path. Hash use file path instead of file name. Documents. Extend. Loader, load. Print. Fill path. Run or execute the above code. That will give you the full path of the file. Now you can use this path to read the file. Loader equals unstructured file loader. Fill path. Documents equals loader load. Now go to a VOVE code. Pip install unstructured. Pip install PDF miner. Pip install unstructured. All docs. And run the code. Click plus Markdown button. This will create a new Markdown cell. Type a title using hashtag symbol. Like this. Chunking the text into smaller part. Clicking plus code will open Python code. Now that we have all of our PDF data loaded, we need to prepare it for our vector database. We can't feed an entire document into our system at once. It's inefficient and can lead to poor results. This is where chunking comes in. To do this, we'll use the recursive character text splitter from LangChain. From LangChain, text splitter import recursive character text splitter. We'll define two important parameters. the chunk underscore size and the chunk underscore overlap. The chunk size determines how many characters will be in each segment of text, and the chunk overlap ensures that we don't lose any critical context between chunks. For this project, a chunk size of 300 within overlap of 50 is a great starting point. Finally, we'll use our new splitter to break up the documents we just loaded. The code will then print each of these chunks, allowing us to see how our document has been successfully divided into smaller, more manageable pieces. Click Add Markdown Title using 2 hashtag. Embedding Documents. 3 hashtag. Vector Stores Chroma Install. Visit python.langchain.com. Top menu Docs equals greater than LangChain link. Right side click Integrations link. Vector Stores page. Scroll down. Select Embedding Model, open AI embeddings. Scroll down. Select Vector Store. In drop-down find Chroma. Click Chroma link. Copy code and paste it in code cell. Clicking plus code will open Python code. Like pip install ChromaDB. Now we get to the most important part of our process, creating the brain of our RAG application. We'll start by converting our text chunks into a format that a machine can understand. From LangChain Embeddings import Ollama embeddings. From LangChain Community Vector Stores import Chroma. Embeddings Ollama embeddings. This is done through a process called embedding. We'll use Ollama embeddings with the Nomic Embed text model. If you don't already have it, pull the model first. Ollama pull Nomic Embed text. This is a small model, so it should download quickly. Nomic Embed text is an embedding model. It's suitable for local RAG vector search with Ollama, not a chat text generation model. It can't run CLI-like. Ollama run Nomic Embed text. This is the key to our free local AI. It generates a numerical representation, or vector, for each of our text chunks. To learn more about vector stores and their integration with LangChain, click Add Markdown Title using 2 hashtag. Connect Ollama. Clicking plus code will open Python code. From LangChain Ollama import Chat Ollama. LLM Chat Ollama. Base URL localhost 11,434. Model Llama 3. Latest. Finally, click on the Run button to execute the code and get the response from the LLM model. Now let's move on to one of the most powerful parts of our RAG workflow. Retrieval-Q&A. This is where the magic happens. Instead of your AI just guessing, it actually retrieves the right piece of information from your private data and then generates an answer. Add Markdown Title. Retrieval-Q&A. Python code. From LangChain, chains import Retrieval-Q&A. core_chain Retrieval-Q&A, from chain type. Question explain PlayOwnAi ID and name card. Run and execute the code. Boom! You get a precise answer, not just a guess. Let's check out the PDF file. It's same answer according to the PDF file. 10.2. PlayOwnAi ID and name card. After joining, every PlayOwnAi employee will be given a PlayOwnAi ID card which she will use to enter. Let's ask about tokenization. Question explain tokenization. Run and execute the code. And boom! You get a precise answer, not just a guess. Let's check out the PDF file. It's same answer according to the PDF file. Here, we're importing Retrieval-Q&A from LangChain. This chain connects our language model with the retriever. Next, we initialize the core_chain. Notice how it takes both the LLM, in this case, our OpenAI chat model, and the retriever, which pulls the most relevant chunks of data. Finally, we pass in a question. Explain tokenization. And the AI gives us a clear answer. Not from thin air, but from the knowledge base we connected. And that's it. Now have a fully working retrieval Q&A system. AI can look up answers directly from our own documents. Support line. Get assist. Stuck anywhere, or feeling overwhelmed? No worries. You can view the full workflow directly from my GitHub. matinix/milm/blob/main/ragum.md. Just follow the link in the description. For more tutorials and smart automation tips, visit my YouTube channel @PlayOwnAi. Still need help? Feel free to drop a comment below. I personally reply and I'm happy to assist. Thanks for watching. If you found even a bit of value, please subscribe and hit the bell so you don't miss my next AI automation guide. Your feedback helps me create the most useful content possible. So, what's on your mind? Tell me what you're struggling with in comments. I might just build a full tutorial on it for you. We release new videos every week. Let's build smarter together with PlayOwnAi Playground.